So now we have a value inside of the function again. So that's going to move things left and right. The first one, how is that going to move your graph? Pi over 6 to the right. So how we're going to do that, I mean, determine the phase shift, so we've already said what it is. But again, we're going to graph this. And the technique we're going to graph for shifting things left and right is we are going to first graph it as if there was no shift. So what does the normal coast graph look like? Well, it goes up to 1, down to -1, has a period of 2 pi. We would split that into 4 equal sections. That doesn't look quite equal. There we go. Here we go, there. That's better. And pi over 2 and 3 pi over 2. And a coast graph starts at the maximum, to the middle, down to the minimum, back to the middle, back to the maximum. I'm just going to temporarily graph it, so I'm going to use a dotted line. Are you okay with that being your coast graph? Sure. So now we need to go pi over 6 to the right. So as far as figuring that out, we need to figure out how much is pi over 6. Here's pi over 2. That's 90 degrees. Pi over 6 is 30 degrees. Does it make sense that we're going to have to move 1/3 over to go pi over 6 to the right? So I'm going to take each of these key points that I have and move, imagine going this amount to the right. And I'm going to take each of my original points and move them pi over 6 to the right. And now we have our new graph. Woo. Shifted pi over 6 to the right. Oh, I guess that's part B. Perfect. Yes? Right, that's a good point. It does say that our domain should be only between 0 and 2 pi. So technically, they wanted us to stop here when it's still going up, because it would technically go to that point, and stop there. But we wouldn't know exactly where those values are at those points. Wouldn't be easy to figure out. But it does say for us to stop here and here, according to that domain. For the most part, though, we will be graphing things and labeling them all the way across. Yes? So they're just wanting you to graph a small section of it. And sometimes what's helpful is to graph more of it and do exactly what we did here, is that once you've got too much, you could erase what you don't need. It's telling you that for all the values within that range, everything is possible.
So within that range, not still
or
sketch it in that domain, but the actual function as a domain.
The actual function, if this wasn't here, would continue forever.
So
Yes.
So that's what you would put down as a domain.
Yeah.
What if you put like, what's it called? The exact values, not XER, exactly right?
I'm not sure what you mean there. Like, this one has a domain of 0 to 2 pi because that's what's given, and it stopped here and here. If this wasn't given, the domain, anything is possible to put in, then you could say XER. Still have no question? Okay. All right, we're going to do this is 3E and F on this one.